Dear friends and visitors, please be sure to click on the red link below. I just spent a full day at WordCamp 2012 at Orlando, Florida, trying to learn how much more I can improve this site. Wow, I certainly have a lot to do. Thanks to all those WordPress volunteers responsible for organizing this event. Job well done, much appreciated. Today's post is an embellishment of the May 7th, 2012 post on the solar future from the eye of a 12-year-old's solar cells in 3D. Life is simply delicious when the confluence of my three hobbies, origami, math, solar, will play a part in our energy future by boosting the efficiency level of solar panel. For those of you who have been following this site, which is this Sun is the Future site, sunisthefuture.net, for almost 2 years, hopefully you have come to realize the three difficult triad historically associated with being the barrier to prevalent implementation of solar energy is cost, efficiency, and battery storage. Our previous post in November 27, 2012, reported on the dramatic decline in cost of solar energy. I will present to you in today's post an interesting way to increase solar efficiency, followed by next post piece on battery storage. And feel free to click. And I have a wonderful presentation by Robert Lang, The Math and Magic of Origami, selected from TED Talks, demonstrated the use of origami concept in increasing solar efficiency. And here it is. Feel free to click on it. Regardless, be it from researchers in MIT, Virginia Tech, or the team William Yuan, they have all utilized the origami concept to dramatically boost the efficiency or power produced by solar panels, ranging from doubling to 20 times or more than the traditional fixed flat panels claimed by some researchers or experimenters. The origami-like 3D solar structure is much more efficient than the flat panels, absorbing more light and generating more power than a flat panel containing the same area footprint. The idea is that all unused light, which has been reflected off one panel, will be captured by other panels. Panels of this type is most ideal in situations with limited space. This was a fully bio-inspired idea. I was hiking up at the Lake Tahoe in California and noticing the shapes of trees and wondering why do they have a given shape over another, said researcher Jeffrey Grossman, a theoretical physicist at MIT. In the past, researchers in photovoltaic panels have kept these panels mostly flat to prevent any shadow effect, because shadowing would diminish the amount of light panels harvest. Furthermore, 2D panels are easier to install on rooftops and better suited for large-scale fabrication techniques. Scientists now use a genetic algorithm in a computer simulation to determine the optimal 3D shape for harvesting the largest amount of light for solar panels. This algorithm creates random combinations of flat, triangular, double-sided panels and analyze them in response to the sun's movement across the sky. The best ones are selected to be mated to create offspring. This process is then repeated for millions of generations to see what might evolve. A huge advantage of 3D solar panels is that they require no moving parts and generate an even flow of power throughout the day. In order to achieve this with flat panels, they must be arranged on a tracking system that move with the sun, which is a big bummer since you really don't want any moving parts sitting on your rooftop, Grossman said. Anything that moves can break easily and requires more maintenance. It is exciting that this simple idea will ultimately help to reduce the cost of solar power. We wish much success with these researchers and experimenters in coming up with the optimal computer-generated 3D designs, and have a sunny and bright sunny day. Gathered, written, and posted by Sun is the Future-Susan Sun Nunamaker. Any of your questions, comments, suggestions will be welcomed at sunisthefuture@gmail.com And of course, as always, homepage is at sunisthefuture.net.